One dot is equal to one variant. How many dots there are now? Key variant of concern. Alpha, beta, gamma, delta. Let's say this is the RNA of this coronavirus, and each section, or we call gene, those people who have been vaccinated, they can be reinfected again by the new variant. It affects the infectivity of it. Like I mentioned, the doctor you see dealing with COVID, most of them are contract doctors. So we get COVID plus this comorbidity, then your chance of getting into ICU. Okay, good afternoon. Today I'm going to explain Delta. Actually, not only Delta, I'm talking about how coronavirus mutates and how all these variants comes out. It's gonna be a quite lengthy video, but I hope through this video you get a new understanding or a new perspective on how you should adjust yourself or and the people around you, how we should change our perspective to deal with this new normal in a positive way. So without further ado, it's gonna be a bit lengthy. I hope you don't mind but I want to cover every details possible. All right, Delta. First, let's look at the virus structure. Everyone knows this is coronavirus because of the corona, the crown that makes it coronavirus. And the virus spread, okay, it's just like a raw piece of paper. Imagine the SARS-CoV-2 is the name for the virus. COVID is the name of the disease. So SARS-CoV-2 is the original one, the very first in the news is Wuhan, but some say it's originated somewhere else, so we won't. But the one identified is the sample from Wuhan. So imagine this is a raw copy, initial copy of the virus or the genetic or the RNA. So it's just like a photocopy machine. Keep on copying and then duplicate and through the copying process, actually some of the information is altered. Imagine just like back then when you're in high school, I mean my time in the 80s, so we tend to photostat book because some books are very expensive. But if you photostat one copy, and then your friend borrow your photostated copy and then copy another copy, you will find the information or the clarity diluted or maybe some noise included in the process because it depends on the photocopy machine. So the same concept applies to the duplication of SARS-CoV-2 virus 2 and then it's spread around the world. So each layer there will be some of the mRNA code will be off a little bit. That's called mutation. So one layer by layer, and then eventually you will see, and you compare the latest version of the SARS-CoV-2 we have in the current patient, then compare to the sample or coding of the RNA coding, then you will notice a big difference. So just like this picture, just a diagram to give you an understanding. So let's throughout the process, I mean, it's not all mutated or some variant, they just cannot survive. And some somehow prosper because of the change of properties. So scientists managed to identify these few variants and then they code it based on, there's a name, they put a code on that. So they code on that, this is the genetic mutation type 1, type 2. So they name it in such a way. But it's very hard for media or people to discuss it. So eventually people naturally tend to use the place, the UK variant, the England variant, that originally happens or that spread mostly of that variant, particular variant. So we have South Africa, Brazil and India and then the Peru. So these are the things, and the same thing apply for the initial outbreak which is at Wuhan. But you know Wuhan, why they don't use the name Wuhan? Because Wuhan virus, because it will cause long-term discrimination or the image is not good. So they change, that's why they come up with a name SARS-CoV-2. And the same apply to this naming. It's not appropriate to use a country name to name a virus. It's not appropriate. So they think of, okay, about 2-3 months ago, about in April or early this year, so they changed to, okay, we use Greek alphabet, alpha, beta, gamma, delta, and lambda to describe, to easier to discuss this type of variants. But it's not only 5. Actually, they have epsilon, zeta, eta, theta, kappa, and iota. And now they are moving, don't know what already. But the last one will be omega because there's only 24 alphabets. So eventually it's not gonna be suffice. Why? Now let me take a look at this mapping. This is from nextstrain. It's a website you can Google, genomic epidemiology. So you look at this diagram, right? So this is how the scientists map all the DNA changes throughout the throughout the pandemic for this particular, actually they are not only map SARS-CoV-2, they map H1N1. It's quite interesting if you are into epidemiology about the transmission of pandemic. So it's very interesting. So it starts with the original one, the SARS-CoV-2, the one that happened in Wuhan back in 2019. Near November. The date is November 28th. So from there on, they start, okay, now I let it run. So actually, the timeline is moving. I play it. So you see, I'm not sure if you can see clearly or not. Okay, John, you try to focus in. So when they're moving, actually, the bright line, this is how they're moving. So whenever there's a dot, that means they recognize it's a change of variant. There's a mutation happens significant. So this is the marking. You see this chart here, this is a new variant that should pay attention to. So, and then here's in around, this is 2012, last year, September, alpha start to appear. And then you see, then the names start to appear. You see this alpha, gamma start to appear. And then delta, alpha, and then as it progressed on year end, because you remember last year 2020, initially everyone thought it's okay already. Then they open up the lockdown, and then the second wave, boom. Then you will see the colors start to come already. Delta, and this is a delta. This is the delta. This is beta, and then the green one is delta. The blue one is alpha. So it's kind of, so you can see the spread. This is how the scientists mark the variants. So there's not only 5 variants, the variants is the dots. Imagine there's so many variants, but only those significant they see is quite dominant. So they name it in such a way. So they classify those very aggressive and spread a lot. It's called alpha, beta, gamma. They call variants of concern. It's really concerning because it spreads so fast. And then another group is, they still name them, but they are not to the level of concern yet, but they are quite aggressive as well. They call it variants of interest. So now people recently, about 2 months, they talk about lambda. Later I'll talk about lambda, but before that, I will look at how the mutation happened and then why there's a new variant and how it affects the properties of the virus itself. But for that, we need to look at the structure of the coronavirus. So you look at this structure. So they are the main one we all know is a spike protein. So the one we vaccine because we want to stimulate body to produce this S protein to stimulate the immune system to identify S protein. But there are other structure of this virus as well. The shell is like imagine the virus is like an eggshell. It has no life, it has no brain, no blood. This is a very simple, we don't call it organism, but it can affect a lot of things. So that, like this protein, hemagglutinin, H, there's the H1N1, the same protein structure, the envelope that covering this virus, the E protein, the M protein, the R, everything, all of this will be coded by the RNA. So this is the RNA. So I use a simplified version. So at least you get an idea what is RNA. RNA is like a code of it, and then it's coded by 4 codes. So the arrangement of this code will determine whether this gene will produce this group of protein, which will, this structure eventually lead to that certain structure. So there are 4 codes in RNA, the adenine, guanine, cytosine, and uracil. So if you, for those people having gout, actually purine ring is this one. So even you don't eat meat, your body still have DNA. DNA breaking down, RNA breaking down will produce this one. So this one will cover in the gout topic. But we go back to here. So this is the coding. So imagine this is an arrangement of this color. So if anything happened during the duplication process or the replication process, one code missed out, we call deletion, or replace. Like the green one replaced with the red one. So the whole code will change. And then the property of the protein produced will change as well. So it's a change of the, so mutation is a change of the arrangement of this code. But since I mentioned RNA, because people confuse, what is RNA, what's DNA? So I'll give you an idea, what is DNA? DNA is double helix. You see, DNA is, they have matching, whereas RNA does not have double helix, it only have one single. So imagine it's just like husband and wife. So if a man have a wife to check on him, so the chance of him going out naughty is lesser. But this one does not have a wife, that's why it has higher chance of mutating. And then also, one thing is to notice is in DNA they use thiamine and there's no uracil. So uracil is only for RNA. This is just some medical terms for those who know, remember a bit of your biology, then this is for your revision. But we are talking about RNA now because this coronavirus, the code carrying is the RNA, not DNA. So, okay, let's say this is the RNA of this coronavirus, and each section, or we call gene, it in charge of the certain features of this virus. For example, this part of it is in charge of the formation of the hemagglutinin protein, and then this part we call in charge of the structure of the envelope. This part will in charge of the structure or how well the DNA or RNA is bound by a certain protein here. But scientists more focusing on the changes on this part. This part will determine the structure of the S protein. Okay, now you get a basic idea, right? So and the protein, right? Okay, let's say I extract this part that in charge of the structure of the S protein. Now let's look at the S protein. Actually, S protein has different, they can further subdivide the S protein structure. The first one, the top part is the receptor binding domain. This is the part that binds to the receptor on your lung cells, okay? The epithelium, we call it epithelium cells. So this is where the binding is. So the structure here determines how well it binds. So the question is to you, in the perspective of virus, is it better to bind better or not? So definitely the stronger, easier for you to bind, the faster the virus or you infiltrate your cells and then duplicate. So this will change the properties of your the infectivity. So this in charge of the infectivity, and then this structure is S protein. They have two S protein, the structure. And so let's say there's a mutation happen. So they name it in such a way because there's like an address. Okay, at the section of 2501, there's a changing of a certain protein from the N, don't know what, I forgot the name, protein, and change it to amino acid, this amino. So this changes the structure of this part. So, and it affects the infectivity of it, I can mention. So if it more affinity to your cell, it spread easier and they duplicate easier, they replicate easier in your body. So you have more viral load in your nose, and then when you achoo, or when you even talk like me, shout in the room, so the virus will spread more because as it go in easy, they duplicate easier, they will higher viral load. Viral load means easier for it to spread. So another thing is, okay, let's say this mutation will change the structure of this one. So this is a whole protein structure. Imagine like I mentioned just now, the vaccine we inject is to stimulate body to produce antibody to identify this S protein. But if the S protein structure has been changed due to the mutation, your antibody cannot recognize it. And then when it comes to here, bang, bang, it cannot, so it bounces. So when antibody cannot bind to this one, it cannot coagulate with this S protein, it cannot stop the virus. So and then your macrophage cannot eat it. So our function of antibody is to bind on it, but the change of structure will affect the effectiveness of the antibody. And as again, like this mutation P681, this is what happened to the Delta variant. This is one of the key mutation happened to the Delta variant, which also affect the structure in a certain way that causes the antibody couldn't bind on it. We call it immune escape. So that's why they say those people who have been vaccinated, they can be reinfected again by the new variant. This is exactly happened. It depends on the mutation or the change of code in that particular part. Alright, so then give a brief video for you, give an idea. This is extract from Coronavirus Structural Task Force. You can find this in YouTube. Bro, if you are the owner of this site, I just want to say I want to borrow your video to help illustration. Right, this is the cell or the cell surface, the surface of the cell of one of the cell in your lung. So when the coronavirus comes, it binds on the receptor we call ACE2 receptor. This is a crown, the coronavirus. So it has a very complex structure. It will come out sending out some messages, and then it try to trick your body, just like spies trying to hide inside your body. And then your body is thought is like something that want to accept. So they send up the control and bro, let me take up your code. Then the coronavirus is like, okay, I'm getting ready to go in. So the code is removed. So this S protein will change structure and then they extend the tentacles, just like an alien that's ready to invade. So they bound to your membrane of your cell, and then they will strengthen it, and then they pull apart, and then they will pull the whole capsid or the cover of the whole virus, and then this RNA will go inside your body, the cell, and then they hijack the resources of your cell, and then they replicate. This is how virus piggyback on your resources and to duplicate. And then at once, it's not 1 to 2, it's 1 to many. That's why the spreading is so fast. So the replication or the replication in your body is fast. So this is the actual code. The one that I mentioned is to give you an idea. This is the agent code done by the Stanford you can find online. They already mapped the RNA code of those variants, the key variants I extract out. This is the Delta variant. This is the S protein. So this is a determine this structure. But like if there's a changes in receptor binding, so this, if you see a line here, this is the mutation. So if you see a line happen on the red zone, which means it affects the receptor binding domain. So there's one layer we call receptor binding motif. I don't want to confuse you. It means as long as you see mutation on the red zone, that means it will cause the virus to more easier to attach to your cell and infect better. It will increase the infectivity. And then if you see the line is happening on the green zone or the blue zone, it means the structure. So if this is a line here, that means the higher it can escape the virus, this variant can escape your immune. So at least you get my idea. But this is what scientists focus on discussion. But actually we don't neglect. They often neglect this part. Because this part will code the other structures. So for example, this part, it changes, it determines how the structure is, the shell. So imagine if there's a lot of mutation in this zone, and then the envelope of this virus becomes thicker or more durable in a harsh environment, which makes the virus more, it can survive longer outside human body. Because as we know, virus need a host in order to replicate and then to piggyback on. But when they are outside, let's say I'm talking now, my saliva is around my laptop kernel, my clicker kernel. So if the shell is not good, right, after maybe like half an hour when I mop the floor, or just like that, it dries and then it dies on its own. But if the structure can last longer, the mutation can make the structure last longer in harsh environment. Actually today is very hot, I'm sweating if I aircon because it's afternoon, 4 o'clock. Last year you heard, right? They say virus cannot tahan the hot water. That's why we have one minister said drink hot water can kill virus. Okay, so but maybe the initial one is cannot tahan the heat lah. But the new version, the one in India, okay, you tell me. India is what is the climate of India? It's hot, right? So the Delta can survive there. Why? No one ever questioned why. Perhaps it's a change of the shell. This is what I assume is. You can do your own research. It takes a lot of time to do all this reading. Okay, back to here. Now we look at the structure, we compare the mutation, the gene of this key variant of concern. Alpha, beta, gamma, delta. Okay, we compare, you see, alpha, the changes in S protein, there are about 10 mutations, whereas beta, there are about 9 mutations on the S protein, and then gamma has 12 protein on the S protein. So gamma is more immune resistant in a way. And all these have the red zone. It means infectivity. But you'll be surprised. Look at delta. Delta only have 7. Only 7 on the green zone. The S protein actually didn't change much. So the infectivity is not much. But why delta is now causing the whole havoc around the world? Because here, the delta can last longer. Imagine like, now I cannot go out, right? I need to post, let's say my product. So I pack it, and let's say I'm tested positive. So I'm talking on the phone while packing, right? So part of the virus stuck on the packing. So when the delivery man comes, they collect it. But if the changes of the structure makes the virus more durable or can resist the harsh environment, so the delivery man may catch it, or the person who receive it can catch it. It can possible. That's explain why now a lot of cases like they've been hiding at home for like they follow SOP, they didn't go out, the whole family gonna. No one can explain why, because sporadic case. So could be because of this. And then last month they said deadlier than Delta. Lambda strain detected in over 30 countries. Whole everyone panicked. But let's look at Lambda. So something news is very funny. They want to have some funny headline to get eyeballs or get more people to read the news. But we, as a educated person, we look at things in a very logical way. We compare. Look at the Delta and Lambda. Okay, expand it for you and let's see. Delta. Look, this is the mutation. Now on this zone structure, which side have more lines? Delta. Whereas move forward. Okay, look at the S protein. 1, 2, 3, 4, 5, 6. Actually, there's one more here. 7. 7 tawo, about the same. So the change of immune escape ability and the infectivity is about lebih kurang sama abang adik. But, and then you look at this end part, which side have more mutation? At Delta. So the change structure. Now, you tell me, which one is stronger? Which one is more fierce in spreading? Delta. So sometimes, I don't know, the news. Okay, I don't want to talk about. So, but when we read news, we have to cross-check the news. So what do we know about the latest COVID variant by WHO? Actually, the Lambda is still under the variant of interest. It's not in the variant of concern yet. It's just sometimes, well, the news media, they don't really filter or cross-check the effect. All right, back to here. So this is another way to give you an idea of the mutation in the way of displaying the data in a different way. So back in 2019, same, originate from one point, and then this virus will start to spread around the world and then spread around with different branch of hierarchy, and then it will spread, and then you see these. This is now where am I now? Now it's May 2020. Still not much. The whole world on lockdown, the first lockdown. And then summer come, okay, people think, oh, the number have got down. In Malaysia, July 1st, 000 for 3 days, right? So the doors start to open, people start to travel, and then start to have cuti-cuti Malaysia. Dapa cannot fly, dapa we can cuti-cuti, and then the whole world is happening the same thing. And then end of that year, second wave spike. The same thing apply in Malaysia. So then you see new variants start to show up. Delta, Alpha, Gamma start to show up. And then until now, this data are recorded on the 30th until 30th of June. So look at this. So now you tell me, can we stop the mutation? Can we stop the formation of new? Is it getting faster, more, or it's going the other way? No, it's going more, it's getting more. We cannot stop it now. So 1 dot is equal to 1 variance. Yeah, how many dots there are now? So until when is my question, but before I answer you that, really good look at this one. WHO finally admits coronavirus is airborne. Airborne means it can spread easily. It means it's just like everywhere. And look at Malaysia, nearly 70% of the cases are sporadic. Almost half, this is when? This is I think 21st June, last month. So because the case, there's so many cases sporadic, they don't know how they get infected. It's just like, now you just imagine the virus is just everywhere. Although imagine you're sitting at home. So then your neighbor kena already positive. So they say, oh, someone said need to go expose to the sun. So he out there, then achoo! Then he blew. The wind blew, and then you were like gardening at home. You get it? Because it's so light, it's so tiny, and so resistant, that's how it spread. So what I'm trying to say, when will this end? The mutation, the answer is forever. It's not gonna end. This is just the fact that we have to accept. We have been living with virus for so many years. Even seen the Spanish flu or Spanish fly. But humans survive, but only those with weak body constitution and the environment is not harsh, they die because the immune can affect them. So even if we manage to vaccinate the whole population, the whole country vaccinate 100%, oh 100%, bagus. But don't forget, because like I mentioned, as long as there is a host for the virus, there's a transmission going on, there's replication going on, mutation is going to happen. You don't forget, we vaccinate human, but we haven't vaccinated the bat. Can you vaccinate the bat? And then you cannot bat, come on, Batman, lie. I vaccinate you, I test you, I swap you. Cannot originate from here. So the virus can piggyback back to here and then mutate there. Eventually, some will leak back to human because human pushing out their land means building all those bird nest house. You are perfect environment for it. So what I'm trying to say, you just cannot escape the virus. Either coronavirus, flu virus, it's gonna be there. So one thing, we need to have a paradigm shift. So calm down and think. SARS, accept this. SARS-CoV is going to stay. I don't mention 2 because there will be SARS-CoV-3, SARS-CoV-4. If you look at the timeline, the first SARS in Hong Kong is in early 2000. Then 2010, there's MERS. MERS in Middle East, there's one deadlier. And then now is about 10 years. So you see that every 10 years, there's one major new variant. Why? Because human change, our lifestyle change, the high rate of urbanization, people concentrate, high concentration of living. We don't live in countryside anymore. Most of the people, we all flock into the city. When you provide a pool for the virus gene to mix around, to duplicate, to mutate. It's just a matter of time, it's just like a cycle. So, but it's not gonna kill everyone. You look at the numbers, it's there, and then vaccine, and then another fact you need to accept is vaccine can't protect us forever. You look at the mutation. If a mutation more on the S1 and S2, the one you have vaccinated, the first 0.1 version doesn't work anymore. Look at this speed. I think maybe 1 or 2 years you need to upgrade your software. I know if you really buy into that. So we can't MCO forever. Look at now. People are getting jobless, business are shutting down. This is not the right way. Does it work or not? You tell me. So the one fact you need to accept is each and every one of us will be infected eventually. Just a matter of when and how. What means how is whether you get into ICU or whether you're in a very samsara way or very torturing way, or you just like no symptom, like that. So it all depends on your immune. So the only thing you need to accept is that we have to learn to coexist, or in Chinese we call 共存 with this virus. I don't care you change the variant or mutant change, but the virus usually they won't kill the host instantly because the host doesn't live, right? That means cannot spread at all. So there's a balance between this, but eventually the determining point is your immune system. So in Singapore, they already start to accept this because it has been 1 year lockdown, open, economy shut down. People are so tired with the numbers, they never stop going. So living normally with COVID, task force ministers on how Singapore is drawing roadmap for new normal. They're trying to coexist. It's like they're trying to accept coronavirus is just like a common cold. Is that okay? Yeah, the mortality rate is higher than the other common cold, but it's still manageable as long as the healthcare system can take care of those weak people. Generally, for a healthy person, generally for the big population, they get coronavirus, they're fine. The immune system will just fight them off. So this is what we are doing now. MCO, CMCO, RMCO, EC, FCO, I don't know what MCO are. So why don't we change the strategy? So we just face it. If you are confident enough, your immune can fight them, just live normally. And then, of course, you need to raise your odds of surviving COVID. But in order to raise the odds, you need to know the numbers. Next, we need to look at numbers. The first odd you need to do is vaccination. Vaccination is just like a first line of defense. This is your fundamental. But remember, this vaccine is designed for the SARS-CoV-2, the initial version. The new variant, they keep on mutating. Eventually, your vaccine just it's not effective anymore because the S protein structure changed until your antibody cannot recognize. So, but naturally our body will learn to adapt, will learn to fight on it. But if you were to depend on the vaccine forever, your body will never learn. So it's up to you. Of course, now it spreads so fast. Of course, we need a mass vaccination to slow it down so we don't spread into people, older people, our family, like old parents. So we look at the numbers. This is the data from Malaysia. I'm talking, of course, I'm living in Malaysia. November 22nd, 2020. So the rate, okay, look at the percentage. Each case fatality is 0.6%. In other words, it's a 1,000 infected positive case, 6 of them will die, okay? This is the number because, like I mentioned just now, you need to increase your odds. But you want to increase your odds, you know what is the main factor that affect your odds. So I'm telling you the factors. So sex, well, male have 65% more chances of getting die from the virus than the woman. And then look at the number, the age group. So this is a tabulation or the spread of the age group of people who die from COVID. So in general, 65% of the COVID deaths are aged 60 years and above. So generally we thought older people have higher chance. Older people have higher chance of getting die from the COVID. But then when from time to time you see on news or 18 months old baby die, and then a young chap 30 years old die from the virus, then people will think, oh my god, it's gonna spreading toward the younger generation. But you don't look at things in a very objective way. Why? Because these young people may have some comorbidities. They might have high blood pressure, maybe they have diabetes, or maybe he's stressed and then he didn't sleep well. That caused him, when he got COVID, he died faster. They only tell you the age, but they don't tell you the features of the health condition of that particular person. They say, oh, healthy. Of course, your blood check is normal, but sometimes insomnia, can you test on your blood works or not? No, right? They cannot tell. So they think blood test or your health condition doesn't really, as you think, you may not be healthy as you think you are. So there might be some underlying condition because people at 30 years old, they don't check the diabetes one. They might have it, but they don't test it. So once they get COVID, of course they die lor. So this is more practical. You look at the comorbidity, it's 87% of COVID death are reported to have at least one underlying health condition we call comorbidities. There's a list of it. So hyperpressure, diabetes, heart disease, high cholesterol, kidney disease. If you have any of this, I mean, when you get kena COVID, then your chance of dying is much higher lah. This is the key point. But look at another data and the newer version until the more updated until April. So this is the data compare the worldwide average of people who die from COVID. Well, on worldwide average, the older, this is we call a very healthy chart, okay, logical lah. But Malaysia, a bit different one, no? 40 plus or 50 or you die more. Maybe with our lifestyle, I don't know, we have more obese people, could be that factor. So now let's look at this, the next one. So look at these comorbidities that can increase your odds of dying because of COVID. Cancer, obesity, lung disease, D stands for disease, gout, stroke, cholesterol, heart disease, kidney disease, diabetes, hypertension. You see, diabetes and hypertension, again, top in the list. So if you have any of these two, try to manage it lah. So this is what we call modern diseases. Now look at the equation. So we get COVID plus this comorbidity, then your chance of getting into ICU or the Cat 4 or Cat 5 stage of COVID or death is much higher. But then what I'll ask you is, can you control the virus? Now you know the mutation is gonna happen forever. The virus is gonna be there forever. It's just a matter of time when you kena it. So you cannot control this, okay? Unless, even you hide at home also you can kena, right? You had sporadic cases. But can you control this one? Yes. This is what within your control. You cannot control the virus, but you can control this. If you can minimize your chance of this, or you control your health, and you manage your wealth well, you take away all these things. So even you kena virus, right, your chance of dying is very, very low lah. If really kena, you still die, then maybe God want you to go with him earlier lah. So you terima hakikat saja lah. So now, act now, instead of staying home, hoping everything go back as before. No, I tell you, it will never go back as before. The virus is going to stay. So it's just a matter of when they kena you, and they kena you, what is the chance of getting into ICU? It depends on you. So survival of the fittest. Virus every 100 years, it just now is faster. There will be a big plague going on. Virus, bacteria, like Black Death kind of thing. They will just cut down some of the human population because we humans is overpopulated. Even this virus or bacteria don't kill us. Eventually, the global warming, now so hot, gonna kill us anyway. So, but whether you are the survived one or going through all these channels or your younger generation, it depends on what you do now, what kind of message you send to them, how to take care of their health, what you eat, exercise. Okay, there's a term in Chinese medicine we call it 正气内存邪不相干, which means if you strengthen your upright qi, 正气, upright qi, we call it upright qi. So then the pathogenic qi, 邪不相干, the pathogen cannot come in. So in other words, if you strengthen your immune system, there's no way to measure your immune system, but you know if you're healthy, you know your state of healthiness. You can look at a person's face and then you look at the eyes, how the way they speak, you know, this is a healthy person. This is the healthy person. Okay, so virus, they're just very hard for them to come in. So this is all I want to say. Disclaimer. Above content is just for knowledge sharing purpose. It's not intended to be substitute for professional medical advice and should not be relied on as a health or personal advice. I'm not a medical professional. I'm just someone who likes to read. I just want to break down the data. And I hope this information can help everyone in getting a new perspective, and then at least you calm down a bit. Don't ganjang too much. Okay, and last thing I want to share is about Black Monday. It's on the 12th of July, already happened. Actually, they say they will strike again. The so-called strike, just wear black shirt. This is what doctor can do. They cannot strike. Now the police also investigate. So the risk of, why? Because they call frontliners is in the hospital, they're dealing with the COVID patient. They are mostly contract MO, medical officer. HO is too young, they don't send them there, but those MO are on contract. The doctor you see dealing with COVID, most of them are contract doctors. So what are contracts? It means when the contract over, the government just bye-bye, I don't need you already. Imagine you put yourself in the shoes, you study so much, you risk your life trying to save other people's life, and you don't get a job security. It means the government can sack you, discontinue your contract, you'll be jobless. You think it's easy for a doctor to find a job? No. So I don't understand why the government don't take care of these doctors that Now we see how important doctors are. This problem does not exist during COVID. It exists before COVID. The contract doctor thing happened in 2016. Now, because no money. Where does the money go to? Build a big building, tall building. Imagine each prime minister go up, build a tall building to commemorate himself. Mati, I tell this country. Imagine this big tower, if can use to house how many ICU, how many patients with or without COVID. They spend the money in the wrong way because they want to push GDP. You spend money on the health sector, the GDP doesn't grow. So your economy doesn't grow, but it strengthens your foundation of the country. Now look, because of your healthcare system, you were not well taken care of, you don't put enough budget there. Now the healthcare system on the verge of collapse, actually already collapsed. Then business cannot run. Where is your GDP? I don't know, politician. Police investigation against doctors supporting Code Black. The Code Black, they say doctors just want to voice out their right, and then police go investigate them. You ask the police go help the COVID patient. Something wrong with this country. So my last thing is I want to pay respect to those MO who sacrifice your time. I know you work 12 hours shift per day, and then you don't have time to rest, and then the stress. I really, on behalf of people, I really thank you all. So I hope those you just support your friend who are doctor. All right, thank you.